All right. So I think that set the stage perfectly for this next panel discussion on technologies and systems. How hard is it to decarbonize the industrial sector, really? A lot of people argue, this is the hardest to decarbonize sector, but some other people might just say, we haven't really spent that much time on it yet. So it's my pleasure to announce the next panel and invite them up to the stage. So we have Brenda Pretrilena from US Steel. We have Sarah Rilling-Hall from Shell USA. We have Grigorios Panagakos from CMU. We have Brian Guzek from the Duquesne Light Company. We have Sandeep Nijhawan from Electra. And lastly, we have Valerie Karplus here from CMU who will be moderating our discussion. Yeah, thank you.
Great, thank you. As our panelists are getting settled, I just want to echo how important it is to keep in mind this broader view as we dive into specific panels that are going to talk about some of the challenges. In this panel, we're going to talk about technology, and I should say we're going to talk about both the challenges but also some of the opportunities. And in front of you, I think you have an all-star cast of folks who have been deep in the weeds and yet working also at a high level within their organizations to chart the way forward in these uncharted waters. And so let me say welcome, everyone. My name is Valerie Karplus. I'm an associate professor in the Department of Engineering and Public Policy here at Carnegie Mellon, and I am delighted to introduce this panel. You will hear today from those who are representing a number of organizations here at the forefront of decarbonization. You'll hear from Brenda Pretrilena, the Director of Global Decarbonization and Program Management at US Steel, from Sarah Rilling-Hall, Shell's emerging energy business, from Brian Guzek, who is responsible for strategy at Duquesne Light, from Grigorios Panagakos, assistant professor in chemical engineering here, focused on CFD modeling for both carbon capture as well as hydrogen systems, and then Sandeep Nijhawan, co-founder and CEO of Electra. So as we move into the conversation this morning, I'd like to just give you a sense for why this is why you have the right voices here in front of you today. So both Shell and US Steel have set ambitious climate goals for their organizations to achieve net zero greenhouse gas emissions by 2050. Duquesne Light released a report last year highlighting how electricity, and echoing some of what Joylette was saying in her presentation, how electricity is a strategy for decarbonization. And at CMU, you'll hear more about the exciting research that is going on in all of our laboratories, and here Grigorios will represent that as well. And then finally, Electra is changing the way we think about industrial decarbonization by making available new pathways to decarbonize the iron-making process. He'll tell you just how their organization can make iron at temperatures around that of a cup of coffee instead of the quadruple-digit temperatures that we need today. So let's move straight into the conversation. You heard this morning for some of the reasons why the industrial sector is so hard to decarbonize. Now, for each of you, can you tell us a little bit about what's hard to decarbonize in your context, and what solutions are you and your organizations advancing? And I'm going to start with iron and steel, so I'll go to Brenda and then to Sandeep.
Okay, good. So I think, Dr. Portlock, thank you. You really set the stage well on why it's difficult to decarbonize in these industrial sectors. And I'd like to set the stage to tell you a little bit about US Steel, and that will help you better understand, our decarbonization journey. We're headquartered here in Pittsburgh. We saw multiple different industries. We serve automotive, construction, appliance, energy with steel solutions. And we have two different steelmaking routes in our operations. We have the blast furnace, basic oxygen furnace route, the integrated route, and then also the electric arc furnace mini mill route. And those different processes use different materials and energy sources, so they result in different levels of greenhouse gas emissions. We do make about 23 million net tons of steel per year, and that's in the US and in our Slovakia operations. We have mines in Minnesota, our Keetac and Mintac mines, where we make iron ore that supplies our facilities. We did set the goal of a 20% reduction in greenhouse gas emissions intensity by 2030, and then our net zero goal of 2050. We have clear line of sight to the 2030 objective. And we have a greenhouse gas reduction task force that's comprised of all of our facilities, and they work on projects that support that 2030 objective. So think of electrification, using emission-free energy sources, process optimization, but really focused on technologies that are commercialized today. So when you think of going from 2030 to 2050 net zero, that's a big challenge, right? And there are a lot of technologies that exist today, but we recognize that we need those partnerships to really advance and commercialize those technologies. And I'd say there are many technologies out there that are yet to be developed and innovated, and I look to the students out there to contribute to that. So in our philosophy, we have cast a wide net, looking at a number of technologies today that support that 2050 goal. So some of the things that we're looking at, of course, future mini mill development, and that's electrification using electric arc furnace technology, CCUS, carbon capture, utilization, and storage, direct reduced iron. Carbon technologies that enable us to capture and use the carbon are very interesting to us as opposed to transporting and sequestering. We know that is still part of the solution. And we actually have an MOU in place with Carbon Free, and I believe Martin is here today somewhere. Raise your hand. There you are. To look at Carbon Free's technology to capture and utilize the carbon at our Gary facility. So very excited about that opportunity. So thinking about the circularity, right? Steel is 100% recyclable. We do have a sustainable product line that uses about 90%, up to 90% recycled content. But recycling in our facilities, reusing water, reusing energy, all of those things become part of that circularity. We have a lot of byproducts that we create today that we use further in the process as an energy source, or using those byproducts to create value-added products and benefits. And here in Southwest Pennsylvania, we have our Claret and Coke operations that produces the Coke, but it also generates coke oven gas. We take that gas, we recycle it, use it as an energy source for Edgar Thomson and Irvin Works, which are both located in this area. So using that carbon emission to create value is a very interesting technology. I mentioned DRI. We do not make direct reduced iron today. We purchase it. So it's not a matter of will we make it, it's when and where. It's part of our roadmap. And we see DRI as a potential substantial user of hydrogen, right? And technologies exist today to do that, but really starting DRI off with natural gas as a reductant and then transitioning to hydrogen when it becomes readily available and cost competitive. So those are technologies that need some development, but do exist today. So I think that, I could go on all day about all the things we're doing to get us to 2050. It's a very exciting topic. But we do have a climate strategy report on our website that really outlines how we're thinking about these technologies. But that at least gives you an introduction. Thank you, Valerie.
Great, terrific. We're going to go to Sandeep Nijhawan, co-founder and CEO of Electra.
Thank you, Valerie. So we, first of all, just to give you a perspective of who we are and what we do, and then I'll come back to your question. So we are a clean iron company. We are a startup. And we produce iron for green steel using lower grade ores and renewable electricity, and specifically intermittent renewable electricity. Just to put the framework for you to think through, Steel is 98% iron. And 90% of its emission, at least the global level, especially with the blast furnace, basic oxygen furnace route, comes from converting the iron ore, which is a reduction step, to iron first. And then when you get to iron, the last step is to get to steel making. So if you are thinking of decarbonization, you really are talking about either doing carbon capture or decarbonizing iron making, fundamentally. So with that framework in mind, we set out to think in a completely orthogonal way as the world is thinking about today, which predominantly is about using hydrogen to produce DRI. And what we have developed is to take lower grade ores that are widely available and are only thing available in context of US, and getting them into, through an hydrometallurgy process into a solution. So don't use high temperatures or pyrometallurgy to melt things, and then extracting iron electrochemically. And the reason we went about doing that is what we have to recognize is we are displacing coal as a source of reductant and a source of energy. And while it is the source of the emissions, it is the cheapest form of energy by far. And if you want parity from a cost perspective, which is what we should all be thinking about, this is a commodity, so cost absolutely matters, then we need to displace that source of energy, i.e. coal or fossil fuel, with something that's cheap. And that today, from a clean energy perspective, is intermittence, renewables, and wind, instead of relying on a base load that could be clean as well. But it comes at a much higher price point to get there. So cost of energy matters a lot when you think about decarbonization, even in context of hydrogen. At the end of the day, cost of energy is what's going to dominate your cost, and cost will dominate what gets accepted as a solution at the end of the day in the market. So we work very hard to solve these two interconnected problems that the world does not have. The world has plenty of iron ore. I mean, our planet is iron, and the crust is made of oxide of iron, which is the iron ore. What we don't have widely available is higher grades of iron ore, which could be used. And as we think about going from blast furnaces processes to, let's say, natural gas, hydrogen, or DRI gate process, you need even higher grades of ore to make that happen. And the reason that happens is in molten pyrometallurgy, like blast furnace, when you melt things, you can, if you have a chemistry background, you can think of slagging is done. You create a slag that removes the impurity. When you have a gas phase reduction process, what you're doing is there's no means to remove impurity in that step. So when you do the reduction, you're actually concentrating the impurities along with iron, which is what you're producing. So the way to overcome that is you have to start with higher grades to feed in, which means more cost to beneficiate. And in order to beneficiate, you have to grind things down. You produce a lot more waste that remains in the mines. And what we have been developing is a process where we can essentially take waste, iron ore waste at a feedstock, and pair that with low-cost energy to make this transition happen at the temperatures, which is 60 degrees C, so there is no thermal mass in this process. So we can, just like a hydrogen electrolyzer, start and stop on demand. And in the language of utilities, we are doing demand response. In some sense, when the availability of electricity is abundant at a low cost, you shift that energy into a commodity like iron. And if the price of electricity is not there, or if the electricity is not abundantly available at a cheap cost, you don't. You stop the process.
Great, and that's a great segue to our next speaker. I'm going to jump around a little bit to stick with this overarching narrative. Brian, can you tell us a little bit about the challenges and opportunities in the electric sector?
Yeah, excuse me, sure. Good morning, everybody. Brian Guzek from Duquesne Light. I'll start with a little bit about Duquesne Light. Hopefully everyone knows us, but if you don't, we're the public utility within the Pittsburgh region, so we have Allegheny and Beaver County. We also have two non-regulated companies, which is the Efficiency Network, which some of you may know as 10, and also DQE Communications. I'm a third generation Pittsburgher. My kids are actually fourth generation, so incredibly proud to be with this panel and be part of Duquesne Light. When you think about challenges from the electricity side of it and decarbonization, and I would reference everyone to the white paper that we've done. It's electrification, as Valerie mentioned, is a strategy to decarbonization. A lot of it is the grid. Is the grid going to be ready? Right? That's usually like, well, you hear from the Pacific Northwest. You hear from, unfortunately, ERCOT in Texas. They have challenges in the grid. I started off by saying I was a third generation Pittsburgher because we've invested a ton in our region in the 40s and the 50s. And if you look at the shorelines and pictures, if you're not from this region, heavy manufacturing up and down. And so, Joylette mentioned, decisions we've made in the past are implicating today. We're very fortunate at Duquesne Light that the robust infrastructure that we put in place in the 40s and 50s, we've maintained it. And not only have we maintained it, we've improved it. Over the last 10 years, we've invested over $3 billion into our infrastructure. And that's a big number. When you think about the next 4 years, we're going to invest another $2 billion. And so we're ready. We're ready as a region. We're excited to have those partnerships. And that doesn't go without challenges, right? Putting the right technology in place, establishing the right partnerships, making sure that we're leaning forward and not, back on our heels when we're thinking about that fourth energy revolution. We're Pittsburgh. We've done it before. We'll do it again. And we're ready to be a true partner at that table. And I'll leave you with this. When you think about our region, and I think Joylette showed the PJM report, and that's Pennsylvania, Jersey, and Maryland. We've moved off of coal a lot in our region, and that's a transition. My father was a coal miner, so definitely a place in my heart. But what that says is that we are leaning forward, and we're starting to leverage some of the zero carbon fuels that we've had. And we've done the math across our infrastructure, and the electrons flowing through our grid are almost 90% from a carbon-free source. So think about that as you're looking at development. The students in the crowd, if you're thinking about startups and opportunities, here at Duquesne Light, we're investing. We're putting things into the region. We're establishing partnerships to people up here on stage. So I'll just say it's exciting, it's encouraging, it's prideful, and the challenges are there. But I think this team, and I say this team, community people up here are ready to tackle it.
Awesome. And I do think of us as a single team in addressing this challenge. I'm going to go next to Sarah. Can you tell us a little bit about Shell's strategy and some of the challenges of decarbonizing your operations?
Absolutely. So you may hear us talk about powering progress, and that's Shell's global strategy. And really what we're talking about is how do we transition to reach that net zero carbon emission by 2050. So we've had a lot of detailed kind of explanations around the technology. I'm going to talk a little bit more about the systems piece of it because I'm coming from a CCS background, right? So CCS is something, carbon capture and storage, for those who don't work in it every day. We think that this is something that will play a key role. It is a proven technology. It's something that does exist out there and is operating today. And I really appreciate the comments that have been made so far because our view is that this is something we need to do as a team. So you'll hear Shell talk about creating CCS hubs or industrial hubs. We want to be decarbonizing our own assets, and we see CCS as a toolkit for us to be able to do that. But if we're looking at our facilities and then we turn around and our neighbors and some of the other companies and industry around us are trying to do similar things on a similar time scale, is there a way for us to collaborate? Can we accelerate the process by being able to build out that infrastructure together? Can we collect the CO2 from multiple different industries and then be able to transport it into a shared store? Does that help us make it more efficient? Does that help us reduce the footprint of some of this infrastructure that's going to be needed? And does that allow us to be able to move faster? So that's really where we're thinking about CCS. I can talk for a very long time about lots of other low carbon products. CCS is one of the tools that we see to really be able to reduce the carbon emissions of multiple different lower carbon products.
Great, and Grigorios, you sit on sort of the innovation frontier in exactly this area, carbon management. Maybe you can speak a little bit to hydrogen as well, in terms of what your work is currently doing.
Thank you, Valerie. Yes, indeed. Are you giving me a couple of hours for that, or? All right. I would say I would like to start. There are many layers. It's a very complex problem. There's not. There are a lot of things that could be said, but let's try to peel off some of the layers here. So I would like to start with one general, statement, or like my motto, which is we need to scale up and scale up technology and scale down cost, and we need to do this fast, and that's what we know. But in order to do so, we cannot leave any technology outside. So we need to be inclusive, and so not a single technology can do it. We know that very well. Not a single entity, organization, government, or administration can do it. So we need to build synergies across the communities, and that's why I think this event is so important, because that's exactly what you're doing. So congratulations to the Scott Energy Institute. So there are challenges that have to do with implementations and challenges that have to do with the technology, core technology itself. In general, if you want to attack a technological problem, you seek innovation in materials, so you develop new materials, you develop a new process, or you do optimal design for devices. So at CMU, we do all three. And depending on what people want and the questions we have, we'll go deeper into that. So if I am to identify some challenges that you mentioned, I would say that there are big three. One of them is scale, because we need to scale up, as we said, and we need to do it now. So the time frame also of the scale up is an issue. So to consider, capturing CO2, if we want to capture, that's a gigaton problem. And gigaton is a big number. By gigaton, you can think about the weight of all the grain we produce on the earth annually, or the weight of all the people on the earth, or order of magnitude. So it's a big number, and this is what the big business needs to be. It needs to be a gigaton business. If we're talking about decarbonization, I did some thermodynamics math yesterday preparing for the talk, for the panel, and if we take the reaction that Sandeep talked about, which is reducing the iron ore to iron, for the iron that we need in the US, it would take around the same grid that we have today in total for electricity in the US. So it's around 4,000 terawatt hours. And that's just the thermodynamic limit without the reversibilities that you need to add on top. So this would be 3 or 4 more times of energy to do that. If you were to do DRI with hydrogen, then this would mean that you would need 25 terawatt hours, 2,500 terawatt hours to produce green hydrogen from electrolysis. And currently in the US, the total, including nuclear, the total non-fossil related hydrogen production is 1,500 terawatt hours. So big challenge out there for us. So the scale is big, and the time scale is big. And the time scale of realizing the transition is an issue, because before we know that this would take decades for us. So if you think when the first automobile was manufactured and when the last person across all continents had access to an automobile, that took around 8 decades to happen. And we don't have 8 decades. We need to compress time. We need to do it in, like 10 to 15 years. So that's challenge number one. Challenge number two is that when we go into carbon capture, we can generate CO2, but we have different sources, different point sources that have different capacity. So we cannot use them in the same way. And if we think primarily about sequestering, which means permanently storing the CO2, then in that case, not all locations have that capacity. And we need to spot specific locations that fulfill safety requirements that we monitor, and we're able to monitor throughout time. So this means that then we need to create hubs where we concentrate CO2 from different sources, and we're able then to inject it underground. And this means that then we have to create a transportation network for CO2, be it pipelines, be it ships, because we may need to store it in offshore locations, not only onshore locations. And this means then that a new supply chain is established or is about to be established. That's also hopefully, an opportunity as well, not just a challenge. And maybe in the future we will start thinking about CO2 also in terms of commodity and not only as a liability. But this has to do with a lot of other things. So now, if I am to talk just a bit about the kind of research that I do and where we come into place, as you mentioned, I come from hydrogen. So in 2009, I was a first-year PhD in Copenhagen, in Denmark, and I remember very well the COP15 then. And I can totally relate with the students attending this event today, as I remember. So this is where I came from, but the last 6 years I have focused a lot on carbon capture. So actually it's a very important, the capture part, because it tends to be the more expensive part. So if we need to develop fast and develop massively, as we need to, and we have this mandate, which is a global mandate to do so, in the US, it has taken the form of legislation with the infrastructure bill and with IRA bill, and we have a mandate which is very concrete from the administration to do that. We need to bring down the cost. And to bring down the cost, we need to come up with new devices that are more compact, are more efficient, and can work better. So the way that we do this is by doing modeling. So we're doing advanced modeling. We combine different modeling tools to devise these advanced devices for doing the carbon capture across many different technologies for absorption, membranes, direct air capture. We're working on all fronts. More specifically, I am using computational fluid dynamics and machine learning to see. We want to demystify the physical and chemical processes that take place in these devices, and hopefully by understanding better what is happening there, we can also attack the design problem. So we are pulling together know-how from CMU and from the Department of Energy that we work with and all the national labs we collaborate with on the revolutions of advanced manufacturing at the same time, and topology optimization and all the other fronts. So we are working together to build this. We are also targeting de-risking the technology for the industry so that we can have faster implementation, and this de-risking involves modeling, and also we are quantifying the uncertainty of these models and trying to reduce the uncertainty so we can make application of the technology more widespread. So I'm going to leave you again with this thought that we need all technologies out there and we need to do it now. Thank you.
Excellent. I'm going to ask everyone to respond quickly to one next question while the audience is thinking of your pressing questions. And in particular, the students, please start thinking of what question you'd like to ask, as we'll be looking for a first question from a student. Let me go down the panel, starting with Brenda. If you could reflect on some of the policy and market enablers. I know Joylette mentioned the new legislation, which makes available a lot of funding, but looking to that and beyond, what, as well as to the market, what are some of the barriers and what are some of the enablers?
That one thing I want to say, I'm a Pittsburgher too, born and raised. I love that introduction. I'm told when I get angry, my Pittsburghese really comes out. But I love this city, so I am a Pittsburgher. But I think, we continue to evaluate all of the opportunities that are presented in the bipartisan infrastructure law and the Inflation Reduction Act. And we've had significant interest from technology providers, labs, universities, different companies that want to partner and support our decarbonization journey. So that's absolutely fantastic. And I think that one of the key enablers, and Sarah really touched on this, is the infrastructure, and Brian, to, for example, if we wanted to use carbon capture, right, at our facility and capture that carbon and take it to the fence line, we need the infrastructure to be able to transport and store it. And if we want to use hydrogen in significant volumes, same thing. We need to have that hydrogen transported to our facilities. So it really solves that chicken and egg problem. It is an enabler to do that. And I think one of the gaps is really that misalignment potentially between this carbon reduction objectives and the market, right? So is the market willing to pay a green premium for green products, right? So they don't exactly align. And, we need to have cost competitive solutions. We do have customers that are interested. We have a supply agreement that was announced with GM to purchase our Verdex low emissions steel, but not all customers of ours are willing to pay that premium for green steel. So the alignment between the carbon reduction efforts, the technology, and the market, I think it may be a gap there. So one thing that Grigorios talked about is commercialization and scale. That is very important. There are a lot of great technologies out there that are at, let's talk about some carbon capture utilization technologies. They're at low volume when you compare to the amount that's generated from a blast furnace or in a facility where we have 4 blast furnaces. So commercialization and scale, of that technology, I believe is a barrier right now, and we have a lot of work to do to scale those up.
When I think about CCS, it's really about the regulatory framework. We have policies, we have regulation that's been in place for a very long time that's very clear when we're taking resources out of the ground. But that framework is still evolving for how we're going to transport and how we're going to store CO2. If I'm going to inject CO2 into the ground, who is the subsurface owner? Who gets to say how we're going to go about that injection? How do we maintain or manage the liability over time? That framework's still evolving. And that's something that would be particularly helpful for us to be able to really move at pace and to be able to scale up, is understanding what that framework is going to look like so that we know those requirements and we can make sure that we're meeting all of those requirements at the right point in time, and then be able to build that infrastructure out to make sure that we're meeting the milestones and the needs of all of the different customers who need that infrastructure at their fence line in order to meet their decarbonization goals. I am not a Pittsburgher, I'm a Buckeye, so I will make a plug for neighboring state. That other part of the policy is that the policies don't end at the boundary of the state. So if we're transporting or we're working with companies and infrastructure across different states, we need to be able to understand how the different states are working together as well.
I think for me, the IRA and the IIJA we can't emphasize that enough. I mean, it's literally the biggest federal program since the New Deal. I mean, it's an opportunity for us all. And you mentioned about, innovating up and driving costs down. I mean, this is an opportunity where we can drive investment up front. And I think you mentioned the chicken and egg problem. Get that investment up front to then start to scale it. Maybe the economics would not work out in a non-invested world, but now that it is, how do we scale that down? And I know ourselves at Duquesne Light, we've put a lot of emphasis on driving dollars to this community. We really emphasize a clean energy future for all. And so when we go out, and we have one right now that we've applied for within the GRIP, so the Grid Resilience Improvement Program within the IIJA, and it leverages a partnership that we have with a company called Line Vision that looks at your transmission assets. So if you look out and you see those real big towers with the real high lines, those are your transmission systems, and we're trying to maximize the throughput through there in a very safe but innovative way using this technology so that we can continue to maximize our investment, right? Maximize the amount of power. You mentioned the amount of energy that we're gonna need. Leveraging the IIJA, leveraging the IRA, leveraging innovation to really show up for this community. That's that's kind of the exciting part about it. When we think about policy, I really feel like the IIJA and the IRA have an opportunity. There's still a lot of questions behind some of it, and that's just part of when you're rolling out a new program, but super exciting for us and the community.
Yeah, I totally agree. I think that particularly those two pieces of legislation, but they're not the only one. We have the scale, also the safe carbon capture storage act as well. So there are many pieces, many tools that now people have to work with and do real-life implementation. That's something that was missing, to be honest. So as others mentioned, Pretrilena mentioned, we have the technology for some time now. So I think that this is the right incentive at the right time to help scale up. Are there gaps? There are gaps, and I think there's going to take the challenge for moving forward is how do we take into the dialogue everybody that is involved, from communities to all the stakeholders that we need to, and at the same time continue to be grounded in technological reality. And how do we bring everybody together to seek the next day? I think that's the most challenging part because it is really cross-disciplinary problem. One thing that I would like to see in the following legislation is for every project to mandate a life cycle analysis and techno-economical analysis that go deep and help us understand each solution that is proposed, what is the effect on these 55 gigatons of CO2 that we are emitting right now.
Okay, so from our perspective, and I'll give a little bit of a contrarian view. It's early in the morning, so let's just shake up things a little bit. Why not? Our view is, or let me just set the stage. I would say that the role of the policy is to be agnostic from a technology perspective. We should all agree to that. Policy should not be picking winners and losers. Markets pick that, depending on what the cost is and how it can address the market needs. So why I go there is that, let's just take a simple example of decarbonizing steel. So we heard about carbon capture. There's a very clear point of source capture in the Inflation Reduction Act for the first time. Thankfully, the United States that actually put a price on CO2 capture. But that's a very different price if you did a DAC, okay? Both are displacing the same CO2 molecule, fundamentally, okay? If you go with the hydrogen route, we have $3 a kilo of rebate. We can debate whether less hydrogen is used or not. I will be stepping into, I guess, challenging a professor from a thermodynamics perspective, whether we have less hydrogen or more hydrogen to be used, but we can take that offline. But $3 a kilo of hydrogen, if you convert that into what is the amount of hydrogen needed in a DRI process to get to clean iron, we're actually talking about $200 a ton iron subsidy as a tax credit, which is about 40% of what the end value is going to be. So that also has incentive. And then if we look at ourselves, or Boston Metal was mentioned in the morning, where if you don't produce a CO2 molecule in the first place because we use clean energy resource, and as a result, don't have to do carbon capture, we actually have no incentive in this. So what we have done here is, in a way, I believe unknowingly, I don't think there is any reason we should think that there's otherwise, that we are starting to give incentives that are not technology neutral. And my concern is that fundamentally it is a lot of investment in innovation, all for it. We have to do it all the way from initial stages of development to Office of Clean Energy Demonstration, OSAD, to LPO, those are all absolutely needed to commercialize any innovation to scale. But we have to be very careful of not to make this thing into, we have to make this technology neutral, is I guess the point.
Great, and indeed, if we want an all-of-the-above solution, there is a strong argument for that kind of neutrality. We have a basis now to sort of, maybe a starting point for starting to think about what that would look like with the current legislation. Now we're going to turn to our audience, and I'm looking around the room for a student question. See a hand over here, and yeah. So please state your name, and I'll assume your organization.
My name is Andrew Schwab. I'm a second-year environmental studies student at University of Pittsburgh down the street. And my question is for Brian. So Brian, you had mentioned how the question and the challenge is the grid going to be ready for decarbonization and that transition? So my question is, what are some examples of those technologies and systems and infrastructure that are going to get the grid ready?
Yeah, first of all, hail to Pitt. I went to Pitt as well, so welcome to CMU Energy Week. I will say, specific example, as I mentioned, the dynamic line rating and why that's important. If you think about any flow of energy, you have generation to transmission to distribution, and if you can't, and the Pacific Northwest struggles with this in their transmission lines. If you can't get the power to the distribution network, you're not going to be able to enhance the distribution network, right? And so we've deployed that technology. We've created data systems that allow us to understand the load profiles across our region and start to then model the load curves from EVs, and we'll just take that as a specific example. So we can start to plan our infrastructure not just 5 years out, but 10 and 20 and 30 as we see the adoption across our service territory. We've also implemented partnerships to upgrade the grid, and why I say that's important. We've done fleet advisory services, so we looked at all the different fleets, whether it's the city of Pittsburgh, whether it's, I keep wanting to call the Port Authority, the PRT, they'll be proud of me for using the new word. We've partnered with them, and they've also seen the benefits, not just from an environmental perspective, but also from a cost perspective. If you look at Petro right now compared to what it costs to fuel an electric vehicle, significantly less, sometimes even 25% of your fuel cost. So we've created that infrastructure, so specific technologies. It's around load modeling, it's around upgrading our transmission systems so that we can maximize the throughput through there, and then continue to invest in areas that are first movers. I think that's important for all of us. We see first movers. I'll give a shout out to West Mifflin Borough. They were one of the first movers in our fleet advisory services. They just implemented charging stations within their borough, and they're taking the next step to look at medium duty, so like garbage trucks and things like that. So hopefully that answers your question.
Great.
Hi, good morning, everybody. Sorry, I still don't know exactly how loud to speak with a mask on. Apologies. I'm Clint Nowak. I'm a former PhD student here. I work at a software company now. It's not super important. I wanted to ask a question about industrial hubs and how that might challenge some of the pillars that Dr. Portlock lifted up around the threat of technological lock-in, given the long amortization times for capital-intensive investments, and the existing interconnectedness of process technology. And you're talking about taking interconnected process technology from one stakeholder and now integrating across integrated systems. And how does that square with the opportunity and the requirement really to leave space open for innovation when we're talking about needing technologies that are commercial now to meet 2030 kind of targets and 2050 beyond that?
Would anyone like to take that question?
Sure, I can talk a little bit about that. So I think one of the things that we have to realize with this is that it's a balance about doing something new but also trying to pull the experiences and the capabilities that we have already. So I can balance a little bit of the systems, but I don't think I'm gonna fully answer your question there. When we talk about building out hubs and capital intensive, we need to know, like Brenda was saying, that there's a certain demand and a certain volume and a certain scale that needs to be there, and we have to start thinking about building that out now to be able to meet that future demand. And that's an uncertainty. And so you're working with a number of different companies to try and align on, I think the comment this morning, the art of possible, and what is it that could be possible, but how much do I actually have to be able to afford and invest now? And when we're trying to do that across multiple different companies, it becomes more complicated, right? Trying to balance that. It's not something that it is something we have done before. There are new pieces when you're talking about technology, though, about tracking. So one of the important things for us when we talk about carbon is if we're taking carbon from multiple different sources, and then we're monitoring it, we're saying how much we're going to inject into the ground, then you have to be able to allocate that back and make sure that you're tracking that in the correct way. When there are incentives for different products and reducing carbon intensity, how do you make sure that you're monitoring that? So things like using AI, using the monitoring, and being able to really hold on to that carbon intensity as you're tracing products down through the rest of the chain.
Great. Sandeep, did you want to?
I will try to answer because I didn't fully understand your question from a integrated process perspective, but putting a system level thinking hat, let's just walk through the value chain for a second. And let's take the one that I'm familiar with, steel, as an example. So you dig dirt out of the ground in the mine. You then have a process to clean up that ore, you beneficiate it. In order to clean up that ore, you grind it down very fine to get to separation happen. And in order to then put in a blast furnace or any other form of a reduction process, you pelletize it. So now you grind, then pelletize. Then you get to the furnace, and let's assume we're displacing coal. So now we need either natural gas or hydrogen as a source, or maybe what we are trying to do. So now we need the access to that infrastructure to get that hydrogen into the system. Let's assuming that we're going for a decarbonization solution, so it's green hydrogen. Then I said that, well, that iron also still has impurities. Then we pass that problem downstream to the steelmaking step to create now another product. Or if you're going with a natural gas route and you need CO2, so which region are you to now sequester that or produce a chemical? So just in this equation, if you look at the system level thinking, just count the number of ands I have put in place here. Okay, just count the number of ands. And I haven't got to communities, I haven't got to the equation of how do we create equity in all of this interconnected domain. So I think one of the challenges, and then to cost, at the end of the day, who's going to pay for all this? We can scale things, but at the end of it, it has to have a certain price point to be adopted without subsidies. We have to get there. Maybe US can afford it, but if you think about global equity, you know how developing nations will get there, or 80% of humanity does not have what we have in this room will get there. So I think from a system level thinking perspective and number of interconnections that I'm just laying this out there, it becomes a quite complex problem. And we have to think holistically in terms of how many of those ands we can actually drop or bypass to get there sooner. And perhaps, maybe the natural gas is one way to get there, cutting down a few ants in there as well, but it doesn't get you all the way there still. So I'm not sure I answered your question, but it is in terms of when I look at the number of interconnected problems we are trying to solve, and how many of those pieces have to come together is I think, the problem of the day.
Great, yeah, and of course these are not isolated issues. The next two panels will pick up on this conversation, talking about how to overcome some of the financial barriers in that context. Looking around the room, do I see? Yes. Next question.
Is this on? Hi, Tim Thiel with Covestro. Recurring theme, I'm a Pitt grad. I couldn't get in here 25 years ago at CMU. Question, I think, for U.S. Steel and Shell. We're looking at the IRA as well. I mean, when it came out in August, we're a large chemical company. We're really excited. We have a DC group and then consultants, what have you. And the way these bills work, they come out and then guidance is written by the department. So DOE, EPA, there's one called the Greenhouse Gas Reduction Fund. All this money basically says not-for-profits, no. So we're in an industrialization decarb conference, and the majority of that money we're kind of being boxed out of when I look at that bill. So I'm curious what you guys will do to kind of get to those dollars. So for instance, we would have projects at our plants we can do, cut our carbon emissions down to 0, but we're not in scope. So our only scope would be to try to work with the local city or governments where we are, or universities. So I'm curious how you not-for-profits will plan to kind of go after those IRA monies, because it's kind of a catch-22. We have the large emissions, but then all the guidance says, no, you're a not-for-profit. Thanks. Or, no, you're a for-profit, I'm sorry.
Right. So if so if I understood the question correctly, you're asking about how do you get around the fact that for-profit organization faces some challenges in going after the DOE money, and I guess maybe if you want to speak broadly or briefly to that, we'll have plenty of time to deal with that on the policy and financing panel, which will be this afternoon. But any quick thoughts on any challenges, barriers, or around the legislation specifically? And if not, we can.
I have a tactical comment before we turn over to Sean, U.S. Steel. Be thankful that you don't have to be the PI if you've ever had to lead that and drive that. So I would say a lot of the nonprofits that, yes, I understand, feel like getting boxed out, but they're good at it. They have infrastructure to be able to drive it as the PI. And so I would just say, yes, I understand you feel like you're being blocked out before I turn over to the colleagues here, but also be thankful that you don't have to be the PI. It's a lot of work.
I can attest to that. And I think we'll have, any other thoughts on this?
Just to, there are so many opportunities out there with the Bipartisan Infrastructure Law and the Inflation Reduction Act. And I think this is a great opportunity to partner, right? So what value do you bring to one of those and partner? So, we partner with technology providers, universities, I've mentioned this before, other companies on these particular opportunities. And I'll give you an example. We have one award from the DOE to look at direct air capture. And the reason we're doing that as part of a FEED study is to help develop that technology, but also using our waste heat to power that. But that particular one has many different partners on it. So, I'd encourage you to think of a way that you add value to a partnership with another organization. Definitely, there are many different opportunities out there.
The same. I think that this is just another point to stress bringing together all of the different value adds from these different organizations.
Terrific. Next question from the very back.
Can you hear me? Yes. Okay. Thanks for being here. My name is John. I'm a master's student in engineering and public policy here. And like many people here, I saw the IPCC report this week, which has me very anxious. That feels like we're in that movie Don't Look Up, where the scientists are saying it's coming and no one's listening to us. So with that context, if I could just ask the panel in like a word or two or three, what big solution you think we need in order for your organization to really start drawing down emissions quickly, whether that's a carbon tax or some other solution? What do you think we need to make a big impact here?
Technology, policy, infrastructure, workforce, community engagement, everything's on the table. What do we need? In just a word or two.
Price of Price of carbon.
Did you say that again?
Price on
A price on carbon.
But you can also do that as a tax or price. Either way is fine. But having a uniform price on CO2 is absolutely needed to move faster.
I like all of the above, but I think do and continue.
All of the above as well, and I think it's very important for some of these activities. I'll just give an example, hydrogen. There's a lot of activity in the hub to produce hydrogen, but to have this circular economy and sustain this after these incentives are in place, you have to balance supply and demand. So we can create hydrogen, but if we don't have a way to enable industry and users to use that hydrogen, we won't be able to sustain it. So I think it's very important to have that supply-demand balance.
I can name two. So one, and I think that's something that it's recurrently coming up, it's that you need to think holistically, and you need to pull resources from everywhere you can get them, and solutions are going to be local. So one area will have something that another area might not have, so this will promote a particular technology in that area. You should be able to pick it up and implement it there, and then be able to have a different set of solutions right next door. So I think this is one which means flexibility and open-mindedness and leveraging whatever we have for the better of design of things. And the other thing is that I think that people need to be, and all the companies, and we all have to be ready to move away from the traditional roles that we are used to. So I think that what Brenda just mentioned is important, because she mentioned about, so they are thinking about direct air capture, and they are still interested, right? I know cement companies that, because at some point they installed renewable energy, now they are thinking of what are we doing with this renewable energy? Maybe we're producing hydrogen. Oh, and by the way, we are also capturing CO2. So suddenly a company which was a cement company can now start producing fuels like methanol or biofuels and stuff like that. So you have to be ready for that. And actually, I would say that you don't only have to be ready, but you have to create an aggressive mentality of how can I leverage this opportunity and this change of scenery. So change of traditional roles is there.
All the above. I mean, echo everyone's comments. I like act locally, think globally, right? It's almost in reverse these days.
Do we have time for one more question?
Hi, my name is John. I am an alumnus, Carnegie Mellon, 1967. I think what's interesting is how this panel is setting the stage for the afternoon, because the soft stuff really is the hard stuff. And my question is, how do we ensure that community input is embraced and not neutralized as we go forward into the hydrogen hub projects and so forth? Not only because we have to address historic and ongoing harm that's been done to the communities, but also because the communities have a perspective on the difference between propping up failed business models in their community versus transformational change. And how do we make sure that this money that is a once-in-a-lifetime, once-in-a-generation opportunity doesn't go to the same old? And how do we make sure that the community input is part of that decision? Thanks.
Great. Anyone have any quick thoughts or reactions? Maybe should we just start with Brenda and go down the row? Feel free to pass.
I can't, I'm just going to give an example of community engagement and how it's important in our facilities today. And I know Shell has a great program on how they engage the communities where their operations are. And we have community advisory panels that consist of members of the community in the vicinities in which we operate. And they can be community members, they can be local officials. It's a wide range of individuals that we engage to educate them on our facility, but also making sure that we're able to communicate any changes that go on in the facility and hear their voices. So I think that type of engagement is going to be extremely important, as I'm talking with my hands and moving the mic, is going to be extremely important as we move forward with these large projects. And I'm sure Shell has that type of activity going on with the recent cracker plant.
We do. We encourage folks to come to the table, bring your voice. I think through the infrastructure law, there are definitely mechanisms for that community engagement and making sure that you're thinking about what the community economic, environmental, that development benefit is going to look like. So there is a structure or a framework in those opportunities that says, how do you bring together organizations and how do you make sure that there's a community benefit plan as part of those proposals? How we actually go about doing that and how successful it is one of those challenges because, as we've been saying, there's a lot of different voices and a lot of different perspectives, but we want to hear those.
I think we see it as workforce development. I mean, people want jobs. I mean, let's face it, like this community's tough, they're resilient, and we have a ton of opportunity with all the things that are going on to develop the talent that we have here in Pittsburgh. We've sponsored our electrical distribution training. We've provided 75 scholarships over the next 3 years that we're going to train the workforce of our communities. We want to reflect the communities in which we serve. And so that's a piece of it. And I think, realizing that a line worker, it's a great role, it's a great job, provides an essential service, but it's quickly becoming a clean energy job, right? We're enabling that multi-directional flow, and we're gonna be there to continue to sustain that. So I think, how do we make sure that the dollars and the investment come within this in Pittsburgh? I think it goes back to like acting locally and thinking globally.
Well, in the academia, I think there is a particular challenge with the communication. So we are, as researchers, we like to go out and show our research, and we spend all this time in the lab developing a solution or in front of the computer writing a code, and then we have the results and we want to show them. But that's not always the best thing to do when we need to communicate. So I think that academia and to some extent with our research community in general, I would say, what we can contribute to the social dialogue is the legitimacy of the arguments and removing some of the polarization around the topics by presenting the core, blunt technical truths that are out there. And so this is where I see a new role also for the academics in the future of having a role in this public dialogue there by being in close contact with the local communities, because they're also where we are, where we live. So I would think that this is kind of the incentive for academia to go into that.
So as a startup, we're a little bit early on that point, but I'll just give you my philosophy on how I'm thinking through this part. For me personally, the decarbonization agenda does not move forward unless and until we fully embrace the community engagement piece and get this thing right. It's very difficult to make an argument to communicate to somebody, where are the jobs and what's in for that community. So for me personally, it comes back towards reindustrialization and bringing the manufacturing, reshoring of the manufacturing, and doing it in a sustainable, clean way. So the stuff we are talking about, you put that chemical plant of making iron to feed steel making. Those are not necessarily infrastructure jobs. Those are manufacturing jobs that has a plant that you have a community that supports the plant, and then you have supply chain that supports, all of that piece, and that allows you to create a community around something that is what is needed and is moving the agenda, essentially forward. While we are early stage, I will tell you that, this is very important, I would say, piece to it, including education and workforce development. I mean, we are a 50 people company. Even then, we have a high school internship program. There is no reason for us to invest, and we pay them more than $25 an hour instead of going and doing any other job as a high school student you can have, is to just be part of this thing and go back to your school so that you can go tell your friends that what's in there and getting an education in STEM and being part of this transition and helping accelerate. So we are trying to do a number of things as much as we can, but I cannot emphasize enough how important that is to make this move forward.
And just to add to everything that's been said, here in Southwest Pennsylvania, I'm a recent addition to Pittsburgh, still taking lessons from Brenda and the Pittsburghese. But we've got an effort called the Southwest Pennsylvania Decarbonization Forum, which is led by the Allegheny Conference, Pennsylvania Environmental Council, involves Sustainable Pittsburgh, supported by the Hillman Foundation. And that type of effort is about creating an independent and safe space to develop the trust and the conversations around what does the future look like? How can we get there together? And that can happen in parallel with and synergistically with the types of conversations that you've heard here today. And so I think we all need to prepare on multiple fronts for this transition and empower ourselves and develop our own understanding of what the technologies are and what they could mean for our communities. So I'm going to wrap up this panel. I think we're at time. I encourage all of our standing room guests to come to the front. I wouldn't be a professor if I didn't say that. So there are all these empty seats up front. And we're just so thrilled that you're all here and look forward to continuing the conversation.